Hi, everyone. We're just going to give a few minutes to let some folks trickle in. All right, so that was pretty good. So I'm going to get started. So my name is George Hayes. I'm the Director of Product Marketing here at LogRocket. I just want to welcome you to today's webinar. We're really excited to have Emmi Russo and Anders Wood of Brandfolder join us to discuss how Brandfolder quickly diagnoses and fixes React performance issues. In addition to Emmi and Anders, we'll also be joined by LogRocket's co-founder, Ben Edelstein. Before we begin, I'd like to let you know that a link to this recording will be emailed to every one of you. The recording will also be available at logrocket.com. At the conclusion of the webinar, we will have a Q&A session with Emmi and Anders. If you have a question, please add it to the chat. All questions for Emmi and Anders will be asked by myself in the order that they are received. If you have any questions that are not addressed by the conclusion of the session, feel free to contact us at LogRocket on Twitter or via email. I'll be more than happy to get you responses to your unanswered questions. For those of you just joining, welcome. And now before we get to Emmi and Anders, I'm going to turn it over to Ben Edelstein, co-founder of LogRocket, to go over some new features we've launched here at LogRocket.
Hey everyone, George, can you guys hear me?
Yep, we can hear you just fine, Ben.
Awesome. So hey everyone, I'm Ben. I'm one of the co-founders of LogRocket. And for those of you who are not familiar, LogRocket helps teams quickly fix technical issues in their web applications and proactively surface issues affecting their customer experience. And so today I'm going to show you a demo of a new product feature we have called Funnel Insights. So let me go ahead and share my screen. Y'all good, George?
You can see that.
Awesome. So Funnel Insights helps you understand specific technical issues and user experience issues that are affecting conversion rates in your application. And to start, like, what is a funnel? Well, a funnel is a series of steps that a user takes that is important to your business. So in a SaaS company like LogRocket, we're software as a service, we care a lot about people coming to our website and starting a free trial so they can, experience LogRocket. And there's a series of steps where they view the landing page on our website, they click start a trial, they put in some information, and then they eventually complete the trial setup and they're good to start using the product. And we care a lot about optimizing each step there. We have a lot of e-commerce customers who care about their conversion from someone viewing a product to then viewing the product, clicking add to cart, viewing the cart, typing in all their information, and then completing the purchase. And they painstakingly optimize each step of that funnel. So what you can now do in LogRocket is you can define a funnel. So a funnel is, here's an example, someone viewing a product. So visited this URL, view product, then the user clicked on a button, and then the user finally saw a confirmation screen after they clicked the checkout button and entered their information. So here, once we've defined this funnel in LogRocket, it's immediately showing us all the historical data around what is the conversion rate in each step of this funnel. So 57% of users make it from step 1 to step 2. 86% of users make it from step 2 to step 3. And I can see these numbers, and a lot of analytics tools will show you these numbers. But then our goal is to improve the conversion rate at each step of our funnel. And so I can start by going in and clicking on this second step, for example, and I can say view the sessions that failed this step. So here are all the real users, all the real user sessions that failed, did not make it from this first step to the second step. And if I want to get qualitative feedback, I can go in and I can watch LogRocket session replay. I can watch these real users on this step of the funnel. I'm seeing the video, I'm seeing what they did. Maybe I see I watch a bunch and I see some patterns begin to emerge. Users might be confused, or users are spending too much time hovering over one part of the page, and I really want to focus their attention to what will bring them to the next page. So qualitative feedback like that, watching the real user sessions, is an important part of starting to figure out what can I change to improve this step in the funnel. But LogRocket's funnel insights then goes to the quantitative side of things. And especially when you have thousands or millions of users moving through a funnel in your application, you need to be able to do things from a quantitative perspective using data. And what Funnel Insights does is it takes all of the signals that LogRocket looks at, so all the data we're collecting on technical issues, network errors, JavaScript exceptions, application performance, as well as user experience issues like when users rage click, they angrily click a button, dead clicks when a button doesn't work. And we take all of those signals and then use data science to then figure out which issues have a statistically significant impact on the conversion rate from one step in your funnel to the next. So here, LogRocket is showing you this rage click, this network failure, this exception. All of these had a material negative impact on your conversion rate from step 1 to step 2. And for example, if I want to understand one of these issues better, I can click in. There's some more data around how often this is happening, who's being affected. And then I can watch real user sessions where this issue took place. And so you can see here in the console, here's this uncaught type error. And now what I might do is copy paste this session URL, send it over to my engineering team, and they can debug the issue. And then using LogRocket, once we push a fix to this issue, I can watch how this conversion rate changes over time. So I can hopefully see once I fix this issue, this number, 57%, gets higher as less people fail to move on through the funnel. And I've now materially improved my conversion rate. And so this is our Funnel Insights product. And just one aspect of how LogRocket can help your team improve your web application, improve your user experience, and now quantitatively prove that by making fixes to issues, you're improving important business metrics like a conversion rate. So that's all for me today. Visit us at logrocket.com if you want to learn more. You can also reply to the email that we sent about the webinar. We're happy to jump on a call, show you more about this feature, show you other features of what LogRocket can do. So now I'm really excited to introduce Emmi Russo and Anders Wood of Brandfolder, who have a fantastic presentation prepared on fixing performance issues in React.
Awesome. Well, thanks, Ben. This is Anders here. I'll pull up the presentation on my screen. And can you guys see that okay?
Yep.
And hear me okay? Great. Thank you. And thank you, Ben. Thank you, George. Thank you, LogRocket, for this opportunity. We really appreciate it. This seemed like a really fun opportunity to share this project and kind of share our experience and maybe help someone who had a similar experience, and also potentially get feedback from folks about ways that we could have done it better as well. So many thanks for this chance to share. And we're gonna, George, did you want to do this slide, or am I just running with it?
Nope, I think you guys just go from here.
Cool. Cool. So yeah, like Ben mentioned, we're gonna walk through how we were able to use LogRocket to diagnose some React performance issues that we had in our Brandfolder application recently. And my name is Anders. I'm a front-end developer at Brandfolder. Emmi is a full-stack developer, and I'll just go from there. And like George said, we can answer questions at the end. I've been at Brandfolder for 2 or 3 years. I've had a couple careers, starting with engineering and consulting and energy, and settled nicely into front-end programming, which I love, and I think I'm here to stay. And Emmi, if you'd like to give a quick intro on yourself, and then we can jump into the project.
Yeah, so I'm Emmi, like Anders said. I'm a full stack developer at Brandfolder, although a lot of the work that I do tends to fall on the front end, where I'll do a lot of work with like our API and sort of the connection between the front end and the back end. I went to school for computer science and psychology, spent some time, about a year and a half at Microsoft, and I've been at Brandfolder for 6 months now, probably 7 months, something like that. I'm really, really enjoying it, and I get to be back we're based in Denver, and I get to be back in my home state, so it's been pretty great with them.
Awesome, thank you. So I'll just jump in here, and I will mention too that this whole project we wrote up in a blog post, which is linked at the end of the presentation in case you want to dig into it more. There's more details there. So to jump in here, Brandfolder, where Emmi and I are working, is a digital asset management platform. We're in the business of selling the #1 DAM platform for enterprise usability. We are trusted by the likes of Lyft, MasterCard, Kroger, Slack, and hundreds of other small, medium, and huge companies to safeguard their digital assets. So digital asset management, or DAM, is an industry unto itself. It describes a platform that serves as a central source of truth for you to manage all of your digital assets. There's a couple of players out there, but I can say in a confident and biased way that I do think Brandfolder has the most intuitive and easiest to use and best designed platform for DAM. And so it's, I'll get into the project itself. So the project which led to the performance issue that we're going to talk about was updating this asset modal that you see in the screenshot on the right side here. Can you guys see my cursor when I move it around here? Is that showing up? Yes, okay, great. So here's a screenshot of the UI that we were updating. Emmi drove this project, and it involved updating specifically the edit tab of the asset modal. And just to orient you to some of the pieces here, all the different components we have on the left side is the asset thumbnail and name. And then below that are the different attachments associated with the asset. You might have 1 attachment, you might have 30 attachments. So that's a variable there. On the right side are tags. You might have 1 tag, you might have 100, you might have 1,000 associated with the asset. And then here's the text area for editing the asset description. And so there's a lot of different pieces, a lot of different components to manage those changes. And so we ended up choosing, let me back up one step. We were updating this component to use React. Previously it was using some Rails views, and we wanted a more modern way to handle all this information to improve performance, but also UX, UI. So we used React Context and useContext hook to do that, and manage all the diffs happening in the state for both submitting those updates, but also for the UI experience so that the user understands what's changing. Context and useContext were a really nice thing to implement because it helped us to avoid bulky prop drilling, which we would have had to use, especially because a lot of these components were very deeply nested components where you had, for example, this attachment, each asset has many attachments. The attachment has these different control pieces on it. Each has its own drop-down menu here, the different drop-down items. So it gets very nested very quickly. And so when you're trying to push state to those different sub-components, it becomes very bulky and more involved whenever you're making updates to those. So this was the UI that we were updating. and we shipped it. And then shortly after shipping it, we got some feedback from a customer that was reporting slow, clunky performance when they were using the updated piece of UI. And they reported that to our customer experience team, who reported it to us, and we logged into that customer's account. And sure enough, we found that when we were navigating around the specific asset that they mentioned, it was really slow and clunky, and the browser was freezing up. And in the browser console, we saw that the JavaScript heap memory was growing in the same way that this one is here on the right side. You can see that blue line is growing, and it's never dropping and being garbage collected. This isn't an actual screenshot. I think this is when we were doing it locally, but you get the idea of that memory growing. And so we were able to confirm that there was in fact an issue, and then it seemed to be related to the browser memory. And then from there, we jumped into figuring out how to resolve it. And one of the reasons it was so challenging initially is because we couldn't, it was definitively an issue, but we weren't seeing it in our local development environment. So it's hard to even address the issue when we weren't encountering it day to day. So how do we fix an issue that we can't even see? We went through this process that's laid out here. This is kind of a hindsight application of this process. We did walk through it, but it didn't have these labels at the time, but now it's easier to talk about when we apply these labels. So I'm going to walk through the identify and the reproduce steps, and then Emmi will take us through the diagnose and the fix. And what's really interesting about projects like this, I think, is that so much of it is spent in these first few steps, the identify, reproduce, and diagnose pieces. And then if you've done those steps well, it's fairly straightforward to implement the final piece where you're actually doing the fixing. And so Emmi will walk us through those parts at the end. So the first step was identifying the actual symptoms and drivers of the issue, what we were dealing with. And to do that, we used LogRocket's performance tab. The chart on the right here is that first customer that reported the issue to us. This is their performance chart from one of their sessions where the issue was occurring. And you can see this is the browser memory over time, and you can see it growing, and almost never correcting itself and dropping down. And it's exceeding 3,500 megabytes of memory, which causes the browser to entirely freeze up and not even really function. So it's definitely an issue. We're definitely seeing it manifest in this plot. And just for context, the Brandfolder app works best when this browser memory stays below probably 50 or 100 megabytes. So to have it exceed 3,000 was a significant issue that we really did need to address. So how did we address it and identify it? We used LogRocket metrics to create a chart for browser memory. We selected all sessions where browser memory exceeded 1,000 megabytes. And you can see for this window of time when we were dealing with this, there's a kind of a spike in that due to our updates. And we actually went through and dug into a lot of these individual sessions to help identify what the user was doing to trigger the memory issue and cause these high browser memory to accumulate. And I kind of liken it to building a Venn diagram. Each session showed us these different factors that the user was doing, and we grabbed all those factors from all the different sessions, and where they overlapped kind of helped to identify for us what some of the drivers of the issue were. Because in the front end diagnosing performance issues, it can be challenging because there's so much going on between the rendering, the state changes, the fetching, the updating using responses from the fetching and the endpoint. So it's hard to pin down which specific things are driving the actual issues. So it was really helpful to have these recorded sessions to do that and the tools to navigate those. So moving from identify to reproduce, we took all those factors that we found overlapping from the different sessions, and we injected them into our local environment. And lo and behold, we were able to recreate the performance issue. You can see on the right is the JavaScript browser, the memory in the browser growing. And this is in the local environment when we're clicking through the asset modal and clicking around, mimicking what the users were doing. We were able to recreate that. We did it by adding dozens of attachments to an individual asset. Remember from that screenshot in the beginning, the attachments were on the left-hand side of the asset modal, and we also added a lot of tags, and that seemed to cause the issue when we were clicking in specifically editing the asset details in that text area. So in the local environment, when we had those things in place and we edited that text area, we saw the memory issue, which led us to this initial kind of hypothesis here that maybe it was this WYSIWYG editor that we were using. Spoiler alert, it was something else, but Emmi's going to walk you through how we figured that out and we're able to diagnose the actual cause and kind of the different iterations we went through. So with that, I'll throw it over to Emmi to walk through the diagnose and fix pieces.
Yeah, so like Anders mentioned, we were usually seeing the memory increase happen when people were typing into this description box on the right. And you can see that bar above there is a WYSIWYG. What you see is what you get editor. So, you know, if you want something to be a paragraph or have a heading or be left align, center align, stuff like that, you can do that. And we were sort of just suspicious and maybe a little prejudiced against this WYSIWYG editor. It had caused us some issues in the past. It actually was a jQuery library, and so we were just very wary to begin with. Like, okay, mixing jQuery and React is usually like a recipe for trouble, so maybe it's this jQuery. We thought maybe based on the increased memory, we also saw an increased number of nodes. Like, okay, maybe every time that they're typing, we're actually reinstantiating the jQuery component and it's not getting garbage collected. Maybe something like that is happening and causing the issue. And it proved to be really simple to just like rule out that this was happening, and that was just to straight up remove the WYSIWYG. So we just replaced it with a text area, hooked up in the same way, but without the jQuery instantiation. And we saw that when we typed into that plain text area, we still saw the memory spike. So that told us that the root cause, at least, wasn't the jQuery WYSIWYG. And we had we had quite the journey of just like messaging back and forth, being like, no, I think that it is it. No, I don't, no, it's not. No, I think it is. No, it's not. But once we were finally able to rule it out, we were pretty sure that we were getting close to the real issue, which seemed to be just the fact of inputting text into the modal was causing this memory issue. And so we were also able to confirm that it wasn't just something specific about the description, it just seemed to be the act of inputting text at all. We confirmed that just by experimenting with the other text inputs. So you can see the like asset name on the upper left, that's just like a basic text input. And we saw when we typed in there that you also got a memory spike. It just so happened that people are a lot more likely to input a lot of text into the description box. So that was where we were seeing it primarily. So we were pretty confident, okay, it's something about on every key press, there's a problem and memory is growing. So when we were originally designing this, our assumption was that it should be just fine to re-render on every key press. Because if you imagine you're just building a component that's only consists of a text input and you re-render on every key press, it should be pretty cheap, right? And our assumption is that the only place that cares about the description is the description box. So on every key press, the only thing that should be having to do any work should be the description box. But clearly things were not cheap because every time you put in a key press, things kept happening and memory kept growing. So our question became, okay, clearly the renders are expensive. Why are they so expensive? And the way that we dug into this was we actually just added a console log statement to the render for every single one of the subcomponents. And it made it really easy for us to just see in the console right away, like in real time, and have a history of it, everything that was rendering. And it was immediately obvious that our assumption was wrong, that every time you made a key press, every single thing in the modal was re-rendering. And it became a real issue when there were a lot of tags and attachments, because every single one of those was re-rendering on every single key press. So you can see that on the right, that list of render generic file edit form, render tags input, 128 render tag components, that happened every single key press. So it was really obvious immediately that, like, if this happens every key press and there's a lot of tags, that would really account for the memory issue and the massive increase in nodes that we saw. So once we were pretty confident about this, which is that, you know, even though tags don't care about the description at all and shouldn't need to do any work to rebuild themselves, it was happening anyways, we were pretty confident that's the real issue. And we were pretty sure that it had something to do with useContext, just because when we were designing this, we were making assumptions based on the way that we had used React before, and that was usually through passing props. And instead, we weren't passing props, we were using a context to update. So we were able to just finally get the right question to Google, which was like, why is context re-rendering every single child component when those components don't rely on that piece of context? And we came across immediately, I think it was the first Google result, this GitHub issue where someone basically had the exact same question, which was that, you know, I have a component, it doesn't rely on this other piece of the context, but it's re-rendering every time. And Dan Abramov actually had a response to this, which is that, yes, when you use context, you can't subscribe to just part of the context. Anytime any of the context changes, everything will re-render, even if it just relies on like a number or a string, and the reference, it's not comparing by reference, it's just looking at the value. What was really helpful was he had three really obvious and clear ways to fix this problem. The first is that you can split up your context. So everything that we had was packed into one context, and that's why when the description changed, the context changed, and the tags changed. So that's really the best way to fix it, is to split things into multiple contexts, because that way you don't have to do any special handling to prevent all of these extraneous re-renders that don't need to happen. They just aren't going to happen to begin with. And it sort of preserves the React way of doing things. Unfortunately, that would have required a fair amount of architectural changes for us, and we really just wanted to get a fix in and get it out and resolve it for our customers. So what we ended up going with is using the use memo hook. This allows us to memoize a component and directly control when it reinstantiates, or re-renders. So we used it for, I think, the attachment list and the tags, since those seem to be the main issue. And we were able to say, okay, only ever re-render if these exact things change, and don't worry about the rest of the context. So we were able to say, don't re-render the tags when description changes. This was really efficient. It only took us a couple of lines of code. And once we were able to, it was really easy to fix. And once we fixed it, we were able to get the fix out into production like that day. So it's really efficient. The only problem with it is that it's not really the typical pattern of React that you would use. It also makes it a little hard to read. We were a little worried about, like, in the future, if someone comes back to this, they're going to wonder, why is this random use memo here? What's the point? If anyone fiddles with the dependency array trying to fix a lint error, it will reintroduce the problem. So those are concerned with it. Long term, we'd really like to split into multiple contexts. It's just something that requires a little bit of work and finagling, and we haven't had the chance to do it. I'll also mention there's one other solution, which is splitting your component in two. So one's receiving the context and then passing those props as props into like a pure component. So that way you also have the fine-grained control, but you're using it through props instead of a dependency array. And then that just required a little bit more restructuring and reorganization than useMemo did. And useMemo honestly was like the first one that we got to work really quickly. So that's what we ended up going with. So I also have just like a snippet of the code, sort of the most straightforward piece where we used it. Pretty much the only change here that we made was adding this use memo around it and the dependency array at the bottom. So we were able to say, okay, when attachments, on every render check, are attachments changing? If they're not, like if description changes, don't bother. If the asset name changes, don't bother. You don't need to worry about it. We know for sure, and we can just tell you. So like I said, it was a pretty easy fix for us once we actually figured it out, and we were able to get it into the hands of our customers and just resolve their issue. Yeah, so that's pretty much it. That's how we fixed it. Everything feels really obvious now. Like hindsight is 2020, and so looking back on it, it feels a little frustrating to be like, of course this was the issue. If we had just read the documentation more carefully, or if we had been in the right mindset when we were thinking about it, or if we just did that stupid console log first, like we would have figured it out so quickly. But I think the reason why we ended up doing this write-up was to remind ourselves that like, it's not always that straightforward, and a lot of times you feel just a little like adrift at sea and not knowing where anything is coming from. So we aim to really just like remind ourselves of like the steps that it took, and like eventually we did come to a solid solution and really understood the problem and fixed it, instead of just, you know, doing a bunch of guess and check and praying. Yeah, so just a lot of this was honestly a reminder for ourselves that in the future, like, even if it seems like you're never going to figure out the problem, you will, and here are some steps that you can take to try and make it easier on yourself.
Emmi and Anders, that was great. Thank you so much for doing that. Again, so we're going to open the floor to some questions. If there are any, please feel free to put them in the chat or put them in the Q&A. I'll relay them to Emmi and Anders. So while we're waiting, I think first question I have is, you know, earlier in the presentation, you mentioned how you used LogRocket to reproduce a specific error, and then you went into metrics to kind of see how pervasive that error was. So why is that so important to be able to see the problem both at like an individual user level and then how it's pervasive throughout your application?
Yeah, so I can take that. The main issue where we really felt like we were floundering was we just didn't know exactly how to trigger it and what the exact symptoms were. So we could sort of see like a slight, like you saw in a lot of those screenshots, because they were our earlier screenshots, a growth of like maybe up to 200 megabytes, but like we weren't sure if we were actually reproducing it, and we couldn't get the browser to chug in the same way that we knew the user was experiencing. So one, it was really important to see this performance tab where it was like, oh no, the growth of memory is so much, like it's so much larger of a scale than we were expecting. And two, we were able to see when that spike started happening. And by looking across a bunch of different user sessions, we were able to see like, oh, here are the things, like Anders mentioned sort of this Venn diagram of like, here are the things that those users have in common. Because it wasn't a huge number of users. It was like at most 20, maybe. So we were able to finally figure out like, okay, what's the common denominator versus just a bunch of guessing and checking and hoping.
Great. Any other questions? Or okay, we have another one. So when you're having a performance problem, why is the context of what the user sees so important? Like, how did that help you guys in reproducing, diagnosing, fixing this problem, in getting that sort of exact replication of what happened to the user, rather than just sort of them talking to you about it?
Yeah, I can take that one. It's kind of I think an extension of what Emmi just detailed. There's with the performance issues, there's it's not always the one thing that the user is doing that is the cause of the issue. In this case, the user typing into that text field was triggering the issue, but that wasn't the cause of it. So it was so invaluable to see through those user sessions all of the other things that were going on when the user clicked and typed into that text field. And without seeing the context of that session, it would have just been shooting in the dark, trying to come up with the solution. So we really needed to see that the user had a lot of attachments, that the user had a lot of tags, and those were the factors contributing to the performance issue that was then triggered by editing that WYSIWYG text area. So it was important to have the context of all those other factors, because just knowing that it was when you type, if I'm sure when they called in our customer experience team, they said, hey, when I type into this to edit the description, everything breaks and it gets really clunky. And
yeah, I think their exact,
with that information, yeah.
From what I remember, their exact statement was just like, ever since the modal changed, things have been broken. Like things are just janky. And so like, and honestly, like that's all they could tell, right? It's like, it was unpleasant to use. Right. So we had to figure out like what exactly is happening and like even what are the specific behaviors that they're seeing. And then after that, what are the symptoms of those behaviors?
Got it.
Which of course it's really sad to hear them say that everything's broken because we just updated it to be this beautiful UI, UX and use all this new technology. So it was really sad to hear that initially, and I'm glad that we were able to resolve it.
Excellent. So we have a question from Mark, and he says, it makes sense why the experience was slow for the user. Did you find out why the memory went up and did not go back down? Were those components still being referenced? Anything like that? Any kind of discovery evidence you've made so far?
Yeah, that's a great. So it's very satisfying to resolve the issue and avoid that performance degradation. The short answer to your question is we don't know exactly why that memory was building uncontrollably. You would expect it to go up when the components render and then down when the garbage collected the next time, which is a expected behavior of React. There's always a little bit of the memory left behind because the next render needs access to the information from the previous render. So that behavior is expected. But to be honest, I don't know exactly why it continued to build in the way that it did. We suspect that there's probably some other really minor memory leaks in the components that are causing those lingering references to not get garbage collected. And it becomes, that issue becomes more prevalent or significant when you have a lot of re-renders where those references are lingering. That's my
we saw
guess.
Sorry, Audrey, you keep going.
No, that was pretty much it. Thank you.
Yeah, I was just gonna say that we did a little bit of research into it and didn't get a very satisfying answer necessarily, or really it would have required like a lot of pretty deep research. There are kind of discussions about it and about, it seems like references are sticking along long after they need to. And there are a couple like libraries out there. We saw one that was like React Garbage Collect, I think, that does a little more aggressive of a job of really making sure that all of your components are disconnected and not just like dismounted and that all the references are cleaned up. But unfortunately, we didn't get really to a point in our research where we had a really, really clear understanding of that.
And to be clear, we welcome any sort of feedback or insight that you might have to that effect. That would be great to get that deeper level of understanding.
Edward has a question. He said, you mentioned that you knew Brandfolder's app performs well when the memory in use is below a specific threshold. So he's just curious how you guys settled upon that number.
The number I mentioned that is like the good performing threshold.
Yeah, the good zone, yeah.
Yeah, that's just from experience of us mucking around in the browser and in user sessions and in different environments and seeing how that grows and just what kind of memory the app in general demands. So that was a very rough estimate based purely on kind of anecdotal qualitative experience.
Yeah, it was just sort of the average that we saw, or comparing to like our old version of the modal and looking like, okay, people didn't have an issue with this. What's the memory look like here on average? And it was usually under 100.
Yeah, that's a great question. Because we did, initially when we were troubleshooting it locally, we thought we had reproduced the issue because the memory was climbing up to like 90 or 100 megabytes. So like, oh, we got this. We'll just need to figure out the fix. But then we realized mucking around with a lot of the other user sessions in LogRocket that, in fact, the memory was way, way high, like orders of magnitude higher than what we were seeing. So it was important. We weren't really capturing, reproducing it very well. So there were definitely some iterations of our understanding around that piece of it.
We have a question from Chris. Did you leverage LogRocket's React Redux integration at all? If so, was that helpful in diagnosing the render issue?
We did not specifically. Correct me if I'm wrong, Emmi, but no, we did not specifically. We were coming at it. Well, we were coming at it from the using the user sessions to help us. But that's a great insight. That could be another helpful path to go down.
Yeah, and I will say, like, we did use some of just like React's dev tools. Like, they have this nice React profiler where you can see a flame graph of where everything is re-rendering. Unfortunately, we have sort of our app is sort of a patchwork. Like, it doesn't have a single entry point. We have a bunch of components that are lifted using Rails views. So it's a little hard to see at a glance where all of the rendering is happening, which is why like that console log ended up actually being really helpful to us. Is like, instead of looking at each individual render and the issues with it, we were able to see sort of like the pattern of renders, if that makes sense, just in terms of like React dev tools and stuff like that.
Really, it's such a humble and simple tool, the console log, but it distills it down to very, very understandable and readable feedback of what's going on in a what could be a really complex app. So yeah, it's interesting that was so helpful.
Great. And then another question, what would you do next time, preventatively, proactively, to look for an issue like this? Like, now, knowing what we know now after taking us down this journey.
It's a great question.
Well, I'll say that. Oh, Anders, you go ahead.
Go ahead.
Okay. I'll say that I'll say that I actually have a PR right now to fix a similar issue with another part of our app where I was like, oh, this is kind of chugging when it's got a lot of tags. And I was like, oh, you know what? We're using the same library for React tags. And like, there's a lot of them and it's re-rendering every time you type. And I know exactly what to do to fix it.
Yeah, to kind of building on that, my takeaway would be and has been since this issue to have a little more understanding and line of sight to how the renders are happening as I build out new components or work with existing components. So being a little more mindful of that by way of plopping in console logs every now and then and understanding how the components are rendering and re-rendering, because it is so, usually it's performant enough that you don't notice if a component renders 30 times and it's fine, but that's very specific to the environment that you're working in. And so when that code then gets placed into production and users are using it in very different ways, those re-renders are going to potentially cause issues and like what we saw here. So that's a great question, and hopefully we learn from this and grow as developers and as a product. And I guess that's my acute takeaway from that is better understanding how each individual components are rendering.
Great. Well, I think that's it from the question side. So Emmi and Anders, thank you so much for taking the time to do this today. It's a great story. I think everybody very much appreciated it. So just one more housekeeping item. Anders, if you wouldn't mind going one more slide for me. Join us next time, July 29th. We will be hosting the Chief Product Officer of Karuna Health, Antares Mekta, Would be great for all of you to join again. We'll be sending out emails to that shortly so you can register. And again, you will all receive a copy of this webinar in your email box. And if you have any questions for either Emmi or Anders, or just about LogRocket in general, reply to the email. Thanks again, everybody, and I will see you soon.